Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program, brought to you by Techstrong and Gremlin. My name is Cody J. Brown. I am the host of Techstrong Learning, and we have an exciting presentation ahead. First, I do have just a couple of housekeeping notes to cover. Today's discussion will be recorded, so if you happen to miss any of our session, maybe you have to leave early, or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session. If you have any questions, we want you to send those in to us using the Q&A tab, which can be found on the right side of the screen. Over on that right side of the screen is where you'll also find the chat tab, where we would like you to send any comments or any thoughts you have throughout today's program, or maybe if you just want to let us know from where you are joining. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around for the duration of today's program. So our topic today is Beyond Chaos Engineering, using reliability scores to drive real results. And I'm joined by Ryan Detwiller, Director of Product Marketing at Gremlin, and Andre Newman, Technical Marketing Manager at Gremlin. Ryan, Andre, thank you both so much for joining me. Ryan, do you want to go ahead and get us kicked off?
Yeah, absolutely. Thanks so much for joining today. Really excited to talk about going beyond chaos engineering and how you can use this concept of reliability scores to drive real results in your organization. Those results being more reliable, more resilient applications, and being able to prove it without waiting for an incident. So I'm going to jump right in. I'll talk about what's led us to these scores, how you can calculate them, and how you can use them in practice, and share a look into how Gremlin can help do this in a standardized and automated way. So, of course, if you have questions during this webinar, feel free to enter them into the question box at any time. We'll have some time at the end for Q&A, and I'll throw a few questions in there throughout the webinar as well, just to get your feedback on what we're showing today. So Gremlin has been solving reliability for a long time. Our founders started more than 10 years ago at companies like Amazon and Netflix, sort of pioneers in this space. I'm curious if anyone's heard of Chaos Monkey, sort of like one example of the early ways to identify issues of reliability. Just throw a comment in the chat if you have, or if you haven't, I'd love to hear. And since we were founded in 2016, we've worked with hundreds of companies on this issue. Some of those companies are shown here. These are leaders in finance, retail, software, healthcare, and more. And we've been really fortunate to learn from them and learn with them, helping them build out mature, world-class reliability practices. We've learned a lot about what works and what doesn't work. So I'm excited to share some of those learnings with you today. Then, like I said, give you a look at how Gremlin tackles some of the most difficult aspects of reliability. Then if you're interested, we'll discuss how you can get started at the end of this webinar. So Cody introduced us already, but I'm Ryan Detwiller, the head of product marketing here at Gremlin.
And I'm Andre Newman, technical marketing manager / senior reliability specialist, also here at Gremlin. Good to see you all.
So before we talk more about reliability, let's define it. Reliability can mean a lot of different things to different people. And if you look in the dictionary, reliability is usually defined something like the quality of being trustworthy or of performing consistently well. And specifically when it comes to software reliability, we think that definition holds pretty true, right? We think of reliability as the trust that software is dependable and will work when and how you and your customers need it to. Reliability means having confidence, even during disturbances, that your software systems and infrastructure will work without surprises. This definition may be a bit broader than what you've seen previously, but what we like about it is that it's pretty customer-centric, right? Regardless of what's happening behind the scenes, this is really what matters to your customers. And with that definition in mind, you can see that reliability in the broadest terms is really important. It's become table stakes to have your applications and infrastructure that you and your customers trust to be available when it matters most. But that's also harder than ever to get right. So why is reliability more difficult today? It tracks with some macro trends that have been happening in our industry for the past 10 years or so. There's a shift from monolith applications to microservices and the DevOps model. And I'm sure this is no surprise to anyone on this webinar today. It used to be that applications were updated rarely, maybe once a year or deployed on a single server. And now, organizations, including our customers, are running more complex cloud infrastructure than they ever have before. In many cases, most cases actually, they're running complex cloud infrastructure in addition to legacy in-house infrastructure. They're running in multiple places and with multiple teams. It's distributed and changing constantly. This is flexible, but really complex. There's been a huge move to DevOps, right? Customers are automating the software lifecycle, building and delivering more things faster. And this has put more pressure on making sure our infrastructure is reliable and predictable. And this pressure to deliver things quickly is being driven by cloud native companies, forcing a lot of traditional enterprises to become software companies and to make this transition as well. And the stakes here are pretty high. We've seen a lot of traditional companies decline or even go out of business because they can't keep pace with innovation. But this speed, complexity, and efficiency that's so needed is in direct conflict with reliability. It's incredibly difficult to go really fast without introducing reliability risks. So I'm curious if this is something that you're seeing at your organization. Again, just like let us know in the chat. Are you seeing this conflict play out for you? Every change that you make in software is an opportunity for reintroducing risk. Think of the rate of change where we were a few years ago to where we are today. It's really exponential. So it's no surprise that reliability is becoming a larger issue. And at the same time, our customers are telling us that the cost of that unreliability has never been higher. Downtime is expensive, right? That's sort of the most obvious cost that people think of. We've all seen the press people get when large websites or applications become unavailable. Direct costs for a large retail application can run into the hundreds of thousands or even millions of dollars per hour. So this is a significant impact on revenue, but also customer experience and brand reputation. But the indirect costs can get even larger. Sometimes we have to stop developing software. We have to get our smartest people to dig in and root cause what the problems are. We have to refactor code. We need to do all these extra things to rebuild confidence in our application and our infrastructure, taking a break from delivering on customer demands and keeping pace to fix some fundamental issues. And this leads to slow and manual engineering processes. It's complex and it's expensive. The cost around not having a reliability strategy has really become significant in the past few years. And as we've worked with companies I noted earlier, we've seen there really is no reliability solution for modern development. There's no consensus view as to what the best way is to solve this problem. I know the chat's been a little quiet, but as I go through a few approaches, I'd love to hear, what your organization is doing and what's been working for you or not. So SREs are one approach, of course, right? Organizations started hiring SREs to improve reliability, and they do a lot of great work. 15 years ago or so, when Google introduced the role, nobody had this role. Now about 40% of enterprise organizations do, and we expect that to reach near 100% in the next few years. But SREs are pretty expensive. They're pretty difficult to hire and retain and scale the team in the way that makes sense for the organization. There's a lot of manual work today. There's really no standards, and very little of the proactive reliability work is automated. So there's a challenge with scale when it comes to SREs. Another approach is observability and incident response. These are certainly best practices when it comes to running infrastructure, but these tools only help after there's been reliability problems. They don't address the core problem, which is identifying reliability risks and solving them before there's an issue. And this is because you really can't improve what you can't measure. And until now, organizations could only measure a lack of reliability by looking at incidents, downtime, time to recover, and similar metrics along those lines. All of these measures are sort of a look back that require systems to fail. And when systems don't fail, does it mean you're more reliable or just lucky? Observability and incident response certainly have their place, but they fall short of helping you improve reliability proactively. And finally, chaos engineering. Chaos engineering is one of the best approaches to try and think about driving reliability on a proactive basis. This is where Gremlin started, and we've helped hundreds of organizations to start doing chaos engineering. And they've been able to find unknown vulnerabilities and make their systems more resilient as a result of that work. But we found this is actually a leap too far for most companies. There's a step that's needed before organizations can do chaos engineering effectively. So let's look into that a little bit more. Again, chaos engineering is still really important. When you look at approaches to reliability, it was really the first way to start finding issues proactively, but it's not sufficient. And there's a few reasons for that. We've learned that even with mature teams and really strong champions inside an organization, most organizations find it really difficult to adopt chaos engineering at scale. First, the language alone prevents a lot of organizations from starting. It feels exciting, breaking things, attacks, chaos, but nobody actually wants more chaos in their organization. Of course, that's not the goal of chaos engineering. The goal is the opposite. It's about building reliable, predictable systems. But the language really doesn't help here when you're starting to get, some traction with chaos engineering. And it's clear to us that there are even bigger gaps after that initial barrier. Chaos engineering lacks a clear starting point. What should you target? Which tests and experiments do you begin with? It lacks a way to measure input, to measure impact. Are we viewing the application when it's tested? Are we watching our monitoring tools? Did I see what I expected? And was the test successful? It's really difficult to determine pass or fail for most of these experiments that you do with chaos engineering. And it lacks clear outcomes to show progress to the rest of the organization. It's difficult to prove reliability is actually better because you've done chaos engineering. There are no baselines or measurements that you can work from. So these factors make it really difficult to, sorry, I skipped ahead there a little bit, makes it really difficult to scale up a chaos engineering a chaos engineering practice in an organization. And the tools alone, even if you have sort of best-in-class tools like you would get with Gremlin, they're not enough to build a reliability program. They can be really helpful for advanced teams, but before you get there, you have to make this concept more accessible to users, create more automation frameworks, and more usability around chaos engineering. In short, we've seen that world-class reliability really needs to have a strategy. The strategy needs to be proactive. Reliability has to be measured and improved before incidents. Know what's going to fail before it fails. It needs to be standards-based. There needs to be a reliability standard to measure against and hold teams accountable to. We need baselines and a standardized way to build confidence. It needs to be automated, right? Teams are busy, people make mistakes. Reliability needs to be done in a consistent manner, tested regularly across an organization, and integrated with the software pipeline. So there needs to be a path to automation in this work. And it needs to be built in. Reliability needs to be built right into the team culture, the product, the way software is delivered today. It needs to be part of what we do and sort of run in the background to make everyone's lives easier and our systems stronger. And underpinning, each of these components of a strategy is some form of reliability management. This is what makes a true reliability program possible. We need a way to track our progress along our strategy, determine how reliable our systems are, and have an objective measurement to compare against. This measurement also needs to be easy for teams to digest so they can celebrate the wins and also determine where they need to improve. And to pull back for a minute, this is really what drives our work at Gremlin. Everything we do is in line with helping teams standardize and automate reliability, standards to measure against, and automation so it can run in the background so teams can focus on higher value work. So what does that look like for your organization? Andre is going to show you a demo of how you can do this with Gremlin in a moment, but here's how it works at a high level. So first, you want to baseline reliability across your organization. Determine the reliability posture of each service by running standardized reliability tests against common issues and known best practices. This includes finding and testing your dependencies, right? So by doing this work, it allows you to build a common understanding of what a reliable service looks like, regardless of the team structure, the service, or the underlying infrastructure. And this has been really hard to do. To have a baseline, you really need to have a common understanding and consistent standards on where to start, what to run, what good looks like. And that's where the reliability score can help. The score should be a proactive, standardized measurement of reliability, letting you know if your system is reliable before there's an incident. So once you have that baseline, the next step is to remediate. Having that baseline allows you to identify, prioritize, and implement reliability improvements so your team's pretty limited resources are applied in the most beneficial area, the area that needs for the most effort. And maybe that's that's going to change for every organization. Maybe that's fixing some critical issues in common across multiple services, or really improving the reliability of a few specific services that have an outsized impact on the customer experience. And finally, automate. You should be able to maintain standards with continuous testing and scoring. You'll want to automate these tests once they start passing so that you have pretty comprehensive test coverage and you don't have to think about it unless your results begin to change. And you can use this to maintain standards across your organization. It's that consistent metric that can just be tracked across all teams. And if you do this in software, it opens up a whole range of options, right? You can use this as a gate in your CI/CD pipeline. You can generate alerts and begin to manage at scale that covers 80 or 90% of reliability issues. So here's an example of what those rolled up scores look like in Gremlin. Essentially, it's a dashboard that gives you a view of reliability across your organization. Now, of course, you could do this manually. And we've spoken to a number of customers that have taken the approach of trying to do some sort of scoring, some sort of baselining of this across your organization. But automating it in software really makes it scalable. In this case, the reliability score for each service is going to be constantly updating as new dependencies are discovered, as tests are run, and as tests degrade over time. And regardless of where you do it, with centralized scoring, you can get a sense of where your reliability risks are, which teams are improving, which teams need some attention. It's really a key way to align teams around reliability. And importantly, the score is fully transparent. So you should be able to see what work has been done or not, and know what needs to be done to improve each score. And by making that transparent, by making it visible for each service, that helps you really improve the reliability posture overall. So that last piece, reliability scores, are probably a new concept to many of you on this webinar. Maybe you've tried that in your organization already. In speaking with our customers, their attempts at building this internally, usually don't lead to a ton of confidence. But regardless of the tools you use, I wanted to share a few key concepts to think about as you build a reliability program around scoring. So we'll talk about the unit of measurement and improvement should be. We'll talk about how to determine what healthy looks like, and how scoring is the basis to drive results. So first, we want to use services as a unit we are measuring and improving when it comes to reliability. There are other places you could do this, right? The infrastructure layer, for example, but services are a good place to start for a number of reasons. I'm sure most of you are familiar with microservices architecture, and this is very much in line with that. But in case you're not, right, a microservice is a set of functionality provided by one or more systems within an environment. So think of an authentication service or a checkout service. Microservice applications consist of multiple connected services. And by making each service more reliable, you're making the entire application more reliable. In Gremlin, you define the service by identifying a process running on one or more hosts, containers, or Kubernetes resources. The next concept is monitoring your golden signals to know if a service is healthy or not. According to Google's SRE book, there are 4 golden signals that every team should start with, right? Latency, traffic, errors, and saturation. And these are the essential indicators of service health. Think of it as, if you're monitoring your body, right? Your oxygen rate, your heart rate. Of course, there are other signals that you could pull in here, but these are 4 that are good to start with. And this is what Gremlin uses to determine if your service passes or fails a reliability tests. Most teams already have these set up. So in the application, we'll just pull these in from your monitoring tools. And we support a number of popular solutions out of the box, but we also can support really any monitoring tool out there via webhook, and whether that's in a hosted application or behind your firewall. So these golden signals should already be instrumented to trigger alerts at specific threshold. And that's what we look at when we're running reliability tests to understand if your service withstood that test or not. Now, many of these teams that we work with already have observability in place, but they may not have the alerting set up yet for each service. And we're often asked where to start. So there's a good chance your observability tool already has some recommendations for you. For example, this is out of New Relic's package. They have an out-of-the-box golden signals alerting package. The key is that you set these alerts where you want. So when you run the test, you're defining what success looks like with these thresholds. And you can actually use Gremlin to help you sort of probe those thresholds and understand where the best place is to set them. And by setting these alerts well, it actually becomes safe to run Gremlin in production, right? Which is the ideal. You want to be testing your reliability in production as much as possible. Teams may start with the staging environment, but ultimately doesn't, exactly replicate that real world production environment. And because Gremlin is sort of looking at these golden signals throughout the tests and immediately stops the test and reverts back to the previous state, you can test in real world environments without impacting customers. And finally, to make reliability optional, I'll come back to that score concept, right? There needs to be this proactive and standardized measurement of reliability without waiting for incidents. This is where the reliability score comes in for each service, created by running those predefined reliability tests across common reliability risks. This is how we've set up our scores. So the total reliability score ranges from 0 to 100, and each category is weighted. So redundancy and scalability are at a 25 here, and dependencies make up the rest of that score. Each test is an equal division of that category. So if you haven't tested anything, you don't get any points for that. We provide half points for doing a failed test. So if you've done the work to determine that you do have a vulnerability, there's value in that. And so we provide half points for that. And then, of course, 100 points if you pass a test. And importantly, the score degrades by 25% in a week if the service isn't retested, right? Systems change, and we want to make sure that these services are tested regularly. So we run tests across 4 categories today. We test system redundancy to ensure your systems can withstand the loss of a host or a zone. We test scaling to ensure your system provisions new instances when CPU or memory is exhausted. And we test dependencies in 2 ways. What happens to your service when a dependency has a significant latency, or what happens when you lose that dependency altogether, either through a failure or a network loss. These are sort of the most common risks to reliability, so it's where we start. But again, we expect to add additional tests in the future. So I'll hand it over to Andre now to show you how these reliability scores and show you these additional concepts in Gremlin.
Cool. Thanks, Ryan. So while I start to share my screen, I'll just give you guys a bit of context to let you know what I'm going to be demonstrating. For this demo, I'm going to be walking you through Gremlin's reliability management platform, so you can see how all these concepts work together. For me personally, demos usually work better when there's a realistic scenario that we're applying it to. So I want you to imagine that we're working for a fictional online bank called the Bank of Anthos, and we're, let's say, a site reliability engineer maintaining the website. What we want to do is we want to test its reliability, make sure our services can withstand common failure modes, and determine where we might need to make improvements or make changes in order to improve reliability. So just to give you an idea of what we're testing, this is what our bank looks like. You can see we're logged in, we're able to see our account balance, our transaction history, we're able to make deposits, and we're able to send payments to other accounts too. Now, our customers are trusting us with their money, so we want to make sure that they can always access their accounts, and that means making this application as resilient as possible. So now I'm going to switch over to Gremlin so you can see what that looks like. So when you first log into Gremlin, this is the screen that we see, which is the services dashboard. This page lists any of the services that you or your teammates have already added to Gremlin. And like Ryan was mentioning earlier, service is just a set of functionality provided by one or more systems in our environment. So as an example, we have a user service that's responsible for user authentication. We have a balance reader, which only reads each user's account balance and displays it on screen. And then we also have an accounts database, which is the database that stores all the user account info. And since we're on Kubernetes, each of these services maps to a separate Kubernetes deployment. We could also easily map these to, say, containers or even just processes running on a bare metal host. Really, the key thing is that each of these services can be deployed and managed independently. So for example, like we can have a team that's dedicated to managing the accounts database, another team for the balance reader, and so on. And really the important thing about services is that in Gremlin, at least, these are the unit of reliability measurement and improvement that we use. So in other words, when we're testing and improving reliability, we're doing so on a per service basis, which is why each one has its own separate reliability score. And speaking of, this is what Ryan was talking about in the previous slide. For each of our services, we've ran a few predefined reliability tests and have gotten our outcomes. We could also click into each service to get a full breakdown of the score, but I can also just hover over the chart and see which categories I've tested and how much they're contributing to the final score. So here we see that, of course, now it won't show up anymore, but here we can see that scalability is contributing 1/4 of the points. For redundancy, we have fewer points, and then for dependencies, we have fewer points too. And we see that we have a lot of room to grow. So we should go in and start running more tests to get a better score. But the main thing that this is just a quick, easy, at-a-glance view of where each service's reliabilities posture lie. And really the great thing about this is that if we add each of our services to Gremlin like we have here, we now get this standardized way of measuring reliability for our entire application. And plus, we also get this centralized view of reliability for the application and for our entire team, and even for our entire organization as a whole. So we can use these scores to not just determine where our strengths, risks, and areas to improve are, but also actually manage our teams more effectively. And then we can even update these scores automatically by automating these tests to run regularly, like every week or even every day. And I'll show you a bit more about that later too. So for now, let's drill into one of these services. So let's focus on the balance reader service. So to click on the balance reader, right away, you can see its reliability score. If I scroll down, you can see the different tests that are available and the different tests that have been run on it. You can also see when each test was last run and whether it passed or failed. So this lets you see how much reliability work we've put into this service. And because we group each test in different categories, you can see which risks are present. It's like, for example, this service has fewer points for redundancy, as we saw up here. And if you scroll down, we can see why. We only ran a host redundancy test, and that failed. So while we got half credit, we're still missing out on some really important points. And we also know that we could have this redundancy issue. So let's say if the host that our balance reader is running on goes offline in production, we know that there's a risk that this service will become unavailable. So this just gives us a clear indicator that we should go back in and check this out and try and implement a solution. And then once we have that in place, we can come back in here, rerun this test and make sure that it's working. I also want to show you that Gremlin can also automatically detect network dependencies connected to the service. And the reason for this is that making sure your service can withstand slow or unavailable dependencies is critical. So for each individual dependency, you can run a test to simulate a failure test, or to increase latency to and from that dependency. Each of these is counted as a separate score, but ultimately they roll up to a broader dependencies category, and you can see the contribution to the final score here. But for now, I wanted to show you what it's like to add a new service. So I'm going to go back to the services page and then click Add Service. And for this, we're going to add the ledger writer service. And the ledger writer is critical because, of course, it handles writing transactions to the ledger. So it's a very important part of our bank's operations, but we don't yet have a view of its reliability. So we want to use Gremlin to understand its reliability and ensure it can stand up to these different failure conditions that it could face in production. So the way to define a service in Gremlin is pretty easy. You start by identifying a single process running on one or more hosts, containers, or Kubernetes resources. You link your golden signals. You can optionally set the suite of tests to run automatically. And that's basically it. So I'll show you how it works step by step. So first, in the create screen, the first thing we need to do is give this a name. So I would just call it ledger writer. We select the type of service, whether it's on hosts, containers, or Kubernetes. Again, this is the Kubernetes application, so I'll click Kubernetes. Click next. Here's where we define the individual resources that make up the service. For this one, it's pretty easy. Ledger writer is just a Kubernetes deployment. So I can do a quick search and click on it, and then Gremlin will automatically select it from my list of deployments. And I can just confirm using the tags that this is actually the resource that I want. So I'll click next. Now Gremlin will ask us to select a process belonging to this service. And this is what it used to detect dependencies by examining and evaluating network traffic. There's only one process in this Kubernetes deployment, which is also called Ledger Writer. So Gremlin automatically selects that. If I had multiple, I could go in and try to select it, but I only have the one. So I'll just click next to continue. And now here's where we start selecting our golden signals. And as Ryan mentioned earlier, golden signals are kind of like the base health metrics that you use to indicate whether your service is healthy or unhealthy. And we offer native integrations with Datadog, PagerDuty, New Relic, and a few others as well, including Prometheus. But for this scenario, I'm going to select Datadog since I already have an integration with it. So I'll expand integrations. You can also add your custom ones. I'll just highlight that. But I'm going to select Datadog. I'll click Add. And now we need to paste in the URL of the monitor that our golden signal correlates to. So I already have some monitors set up in Datadog, and I have a URL here that I'll just copy and paste. Once it's in there, I'll click Test Golden Signal. Gremlin will send out a query to that monitor using an API key that are already set up for authentication. And when it gets back a healthy response, it pulls the name of the monitor. So we already see that this one is tracking response time. It shows us that the status code is 200 and healthy. We have a pretty decent response time. And the body returns okay, indicating that this monitor is healthy and in a healthy state. Excuse me. So since that looks good, I'll click Save. And we see the signal gets added. And then typically we would repeat this 3 more times to add each of the other signals too. But again, just for this demo, just to keep it short, I'll just add this one and then click Next. And now we have the option of choosing whether or not to auto-schedule a reliability test. So you saw when we were looking at the balance reader service, we had that full list of tests, the redundancy and dependency and scalability tests. If we check this box, we can have each of those tests run automatically as long as we've either ran them at least once or they've passed at least once. And we can choose the test window to run it for a certain day of the week and also specify what time it starts and how long the tests run for. This is a great way to make sure that you're continuously running your reliability tests and keeping your scores updated and preventing your scores from degrading in case you haven't run your tests in a while. So we definitely recommend that, but for now, I'll just keep that unchecked. I'll click Next. Lastly, I'll just review this summary page to make sure that everything about the service looks okay, and it does, so I'll click Create Service. And in just a few seconds, that service is created. We start off with a score of 0 because, of course, we haven't run any tests yet. But if we scroll down, we see the full suite of tests that Gremlin has automatically created for us that we can just run right away by clicking Run. And then if I scroll down even more, we can see the list of dependencies that Gremlin's automatically detected based on our network traffic. And again, for each one, we can run a failure test, we can run a latency test. We can also edit it. So for example, if this URL isn't totally accurate, we can come in here and change the name of the dependency. Or if we add a new dependency, we can also specify a custom URL or IP address or host name, as well as a port number. So there's a large amount of configurability here. In case a dependency isn't detected that you know is there, you can just add it this way. And then we'll automatically create the tests so that you can run them automatically. So for now, let's start with a really easy test. Like, for example, the CPU scalability test. This test is pretty straightforward. It validates that the service can still perform with limited CPU capacity. What we'll do is consume CPU in 3 separate stages. And ideally, our service will scale and add a new node or increase the amount of CPU so that it can withstand the higher amount of usage. And we can use this test to verify that this was expected. So to run the test, I'll just click Run. Since we are impacting a live system, Gremlin will just ask to confirm for safety. And so I'll click Run again. And now that test starts. And while the test is running, we can monitor its progress on this page. We can see the details of the test. We can see which golden signals Gremlin is monitoring, and also any output from Gremlin while it runs the test, including execution details showing step-by-step what's going on. And we can also halt this test at any time by clicking this big halt this test button here, or the halt all test button up here. And that's just to provide a level of safety so that, let's say, a test starts that has a bigger impact than you expected, or you change your mind and you want to stop it, you can just come to either of these and click them, and it will immediately stop and roll back the test. But for now, I'll just let this run, and then I'll go back to another service where we've already ran a few tests so that you can see what the outcome looks like. So let's head back to our balance reader. And so in the balance reader, again, we can just easily see which tests were successful and which ones failed. So if we scroll down, we can see that both of our scalability tests passed, which is great. That means that our systems can scale quickly and effectively in response to higher demand. But our host redundancy test failed. And if we want to figure out exactly why, we can just click into the last run or the history buttons. And that'll show us the last outcome of the test and what exactly caused the failure. So you see that the reason is that we have this golden signal called availability, and that failed. And that indicates to us that Gremlin, or rather our monitor, was not able to reach our service. So it reported as a failure, and Gremlin detected that failure. And as soon as it did, it stopped the test and it rolled our systems back to normal so that we avoid any unintended outages or keeping the test running for longer than we should have. And we can also use this as an indicator of if the monitor itself isn't reporting back the way that we expect it to, right? Maybe this is a false negative. This tells us that we should actually go back and tweak our monitor to better reflect the health of the service. So there's a few takeaways that you can take from this. And ultimately, both of them are meant to drive conclusions that can help us make our systems more resilient all around. So heading back to the service overview page, Ryan talks a lot about the score earlier and how it's broken down. Just as a reminder, each category contributes an equal amount to the total score, and each test within that category contributes an equal percentage. Again, we get full points for a successful test, half points for a failed test, and 75% if a test passed, but it hasn't been run in the past week. And Gremlin gives points for a failed test because even though it failed, it still shows that we've taken steps towards improving the service's reliability. Really, that first step is knowing where reliability risks are. And as long as you've taken at least that first step, we're still going to give you credit. And again, these points are averaged across each category and then summed together to give the final score. And that's what gives us our objective, up-to-date, and standardized way of measuring reliability of our services. All right, so now that you start seeing how it works in action, I'll stop my screen share and hand it back over to Ryan to wrap up.
Great. Thanks so much, Andre. Yeah, and that's a quick view of the product. That's how we're sort of tackling some of those really difficult issues of reliability. I want to spend a couple minutes just talking about how you use a product like Gremlin or this practice to really drive business results across your organization. So as a first step, use the score to manage teams more effectively by using standards. We can review changes to the score. We can see how teams are scoring relative to one another. We can identify our risks and think about the improvements that we want to make. Now, contrast this with the retrospective meetings that most teams run after incidents today. Teams now have a positive reliability metric, and they can sort of proactively plan what to improve rather than focus on retros after something breaks. The next step is to automate. Now, we should do some scheduling in the application itself. But once you begin passing tests, you can, like I said, schedule them to make sure that the services are continuously validated as systems change. Or you can use the Gremlin API to run tests from a CI/CD tool or sort of really any other tool that's part of that pipeline. And this improves the efficiency of your team because reliability testing is no longer an area of toil, no longer a background concern that just sort of slows teams down overall because they're thinking about it. They can really start focusing on development while Gremlin takes care of reliability in the background. And next, you can use the service reliability score to prevent unreliable code from reaching production by tying into your CI/CD pipeline. You can imagine if we had a condition where we wouldn't deploy new changes unless our reliability score was above 90. So teams would have to shift to fixing those reliability issues if that's the standard you've set before deploying. or if bad code caused one of our reliability tests to start failing on staging where previously it had been passing, you could prevent that problem from reaching customers. So there's a lot you can do with a product to really operationalize reliability and just have it run in the background. These are just 3 of the most common ways we see this being adopted when organizations are looking to scale. So just a couple more notes before we open up for questions again. Throw those questions into the Q&A panel. Gremlin's enterprise ready, right? It's safe and secure to use. It installs really quickly. You can access it via the web GUI that Andre was showing, but also CLI or the Gremlin API. It's cloud agnostic, so we support AWS, GCP, and Azure. We also offer Windows and bare metal support, and so you can really deploy, one tool across any environment. You can manage reliability organization wide rather than relying on a patchwork of tools and sort of different standards for different infrastructure. And all the things that make Gremlin enterprise ready has led us to being trusted by leading companies in many industries to help them build their reliability programs, right? We've worked with banks and financial service organizations, major retailers, healthcare providers, and others. So really quickly, what does it look like to get started with Gremlin? If you're interested, we try to make it really easy. So typically organizations start with a pack of 5 services and a quick start session to get up and running. And we start with 5 because deploying it across a few services from the start provides a good taste of reliability management across multiple services at a really affordable starting price. You can add additional services as you grow and scale, and volume pricing makes it pretty cost effective at scale. And we provide a 30-day money back guarantee. So if Gremlin's not for you, no problem, we'll refund you in full. So from here, just want to say thank you so much for spending some time with us today. I hope this was really helpful for you as you think about improving the reliability of your systems and organization, at the organization-wide level. Hopefully there's some concepts in there that you can think through and maybe adapt that to your organization. So Q&A is open. Feel free to ask questions anytime.
All right, so I've started looking through these and we'll just take them from the top. So are you testing prod systems like shopping carts or etc.? And the asker goes on to say, we are limited in prod, so lots of testing done in lower environments, but we don't detect all functional issues before going to prod.
Yeah, Andre, do you want to take that one or do you want me to take it?
Yeah, I can take that one. In a sense, that actually kind of answers its own question, right? We recommend testing in prod because there is nothing quite like prod. Even if you try to replicate prod in a pre-production environment as best as you can, there are going to be some little differences, little idiosyncrasies that you won't be able to account for. And that's just the nature of these complex systems that we're working on. So you can do everything that you want to test in pre-production, but if you're not actually testing in prod, then you're missing out or potentially missing out on some pretty severe bugs. And, we totally understand there's that apprehension about testing in prod. It's really hard to convince your manager and to even convince the rest of the business that it's a necessity, especially when there's that risk of an outage. But that's why Gremlin takes a lot of effort to make it as safe as possible by providing that automatic shutoff feature and the ability to hit the big red button to stop all tests. So there are things that you can do to make it more appealing, at least less risky to test in prod. But ultimately, the idea is to run these tests in prod.
Yeah, just to add to that a little bit, I think it's a great answer. Most teams will start off in non-prod environments as they build confidence around it, right? But ultimately, you want to be testing there because if you're not running the tests, are you really confident that your systems are actually resilient to some of those common issues, right? I mean, we're testing for the things that are most likely to happen to production environments, and so it's one of those things to try and do it ahead of them happening to you when you're not planning for it, when you're not watching it and not monitoring. And there's a lot of built-in sort of fail safes there to make sure it's not impacting customers.
Well, thank you for that. Our next question reads, is there any way to see the reliability score for an entire team?
Yeah, I can take that. So we introduced reliability scores a few months ago now. Had some really good beta feedback, and we've done that sort of service level score. We're just rolling out these organization-wide scores there and having some granularity in that. So the idea is that you'll be able to sort of set up the scores, the standard permissions view for each team. So, you could have that organization-wide view, sort of the team view for the teams that you care about, or the individual service level as well.
Our next question reads, how do you live test your redundancy?
Andre, do you want to take that one?
Sure. And yeah, it's a really good one. I like that question because, again, there's that pretty obvious, what if it goes wrong, right? If you shut down a host and you only have one that's running your really super critical application, then you're kind of shooting yourself in the foot. In that case, it is actually worth, I would say at least, testing it in pre-production. Set up a similar infrastructure as the services running in production, especially if you know that it's only running on one host or it's only running a single instance of it. Run your test there, see what happens, implement your fixes. Maybe you enable auto scaling or you increase the number of replicas, test it again, and that'll actually give you a better understanding of how that's going to behave in production. I know that sounds like it contradicts my last answer of, pre-prod isn't prod, but in this particular case, I would say that there's definitely a benefit there. In this case, you want to actually make sure that your systems are redundant and can fail over, so that, again, when you run the host test or zone test in production, you don't accidentally take them down. At the very least, make sure that you have some sort of auto restart policy in place, so that if the systems do go down, they're able to automatically come back up, or just be on standby on, like, let's say the AWS console if you're using AWS, so that you can restart that system if needed.
So how do I test something not in the set of tests that you provide?
So we do also provide our more traditional chaos engineering product called Gremlin fault injection, where you can create more custom tailored and more advanced tests. For reliability management, we're really focusing on the essentials of what makes a distributed system reliable. So the goal of this is to be more guided and more prescriptive and just to make it easier to get started. But if you do want to, sort of get your hands dirty and dig in and create your own tests with your own granular settings, you can use Gremlin FI to do that.
Yeah, let's add to that too. I mean, again, this covers a lot of the common issues that comes to reliability, and we have a few more tests on our roadmap that we'll be pulling in here too. One of the concepts we're thinking through right now is, can you build out some custom scenarios, some custom tests, and actually migrate them in so they just run on a continual basis as well. So lots of opportunities to kind of go beyond the core standard testing that you see here.
So are reliability scores replacing chaos engineering?
I think hopefully we answered some of that throughout, but no, I think they certainly supplemented, they augmented. What we're seeing is the reliability score is a way to get really good test coverage of a lot of the common reliability issues across the organization. Just have that standard to work from. But there's probably going to be some of those other scenarios that you want to test out and some other things you want to do, and so that's where traditional chaos engineering can come into play. So I think the scores are probably where most organizations are going to want to get started, but they can certainly use that as a base point to add more traditional chaos engineering on top of it.
So does Gremlin provide certifications?
We do. So I think it's gremlin.com/certifications, if I'm remembering correctly. Certification, no S. There's a couple of different certifications, so you can get started with a chaos engineering certification or the Gremlin Pro certification. Those are more traditional chaos engineering certifications. We haven't integrated the scoring and testing that you've seen for the most part today into those certifications yet. Again, because a lot of the guidance is now sort of built into the software, so there's not a whole lot of additional training you need to do outside what you get from the success team and the rest of the team at Gremlin. But yeah, there's certifications for the chaos engineering side.
Perfect. So I'm not seeing any questions at this moment. I'm going to give away a couple of gift cards, and I'm going to ask Andre and Ryan to look through and make sure I'm not overlooking any questions during this time. So for our 4 winners of our 4 $25 Amazon gift card drawing, our first winner is Manas S. Our second winner is Niru H. Our third winner is Martha M. Our fourth winner is Mark J. So to our 4 winners, congratulations. Please keep an eye on your email inbox to claim that gift card. But if you do not see that email, do check your spam folder. Now, I'll also take this opportunity to remind everyone that this session was recorded. So following this program, you'll receive an email with a link to access that recording on demand. Or you can find the recording living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. So Ryan, Andre, did any more questions come in?
Yeah, I see a couple questions in there that are probably best we can just follow up individually after the session. So you can look for some communication after this.
Perfect. Well, Ryan, Andre, anything that you would like to leave our audience with? Any parting words before we close out?
Yeah, I mean, I'll just say thanks again for joining us. Really excited to share some of the things that we've learned as we build out reliability programs, and sort of regardless of where you are in that journey, I hope there was something for you to take from this session. And of course, feedback is always welcome. If there's something you didn't see or something you'd like to see more of, let us know. Our emails are in the presentation itself, and you can certainly get in touch with us at any time.
Yeah, I definitely echo that and just say that, this is the result of a lot of insight that we've gathered over the years of just helping companies try to navigate these reliability issues, and just our own understanding of working with these really complex distributed systems. So we're really happy to share them. And and thanks again for joining us.
Awesome. Well, Andre and Ryan, thank you both so much for joining me. And Andre, thanks for running us through that demo. I'd like to thank Gremlin for sponsoring today's program. We couldn't have made today possible without the sponsorship of Gremlin. And to our audience, thank you so much for joining us today. We really appreciate you spending the last 50 or so minutes with us. We do ask for 1 extra moment of your time for a brief survey that should pop up on your screen as soon as we close out. But otherwise, we do hope to see everyone at an upcoming Techstrong Learning program. Everyone, have a great rest of your day. And Ryan, Andre, thank you once more.
Thanks, everyone.
Thank you.